Hello there. This is our Yhbp demo kit that we have here at Festo US. I'm just going to walk around here and kind of show you the main components here. So first off, we have the main balancer cylinder, or the working cylinder, vertical orientation. It's also connected to a guide unit for support. We also have a cylinder sensor switch installed here and wired appropriately into the control cabinet. This system is supporting a bunch of weights, so we can take weight off and put weight on to show how the balancer works. Here's the operator control handle. It's a single acting cylinder with a 6mm airline. We'll show you where that goes here in a second. This is our operator panel. The electrical I/O that you see here is obviously not included in the Yhbp kit, although this is the responsibility of the end customer machine builder OEM. So very briefly, what we have here is we have an operating mode. The Yhbp has two operating modes: hold mode or load guided mode. So that's this input here. The next input you have is error reset. Then you can have the ability to turn the handle on or off. It basically just turns off the ability for the proportional valve to move with the command of the handle. And then lastly, we have the operation enable. And then as far as outputs, we have an enable on, we have a system ready, we have an error, and then we have an indicator to tell us which mode we are in. Next thing we have here is, this is kind of an optional thing that we did just for this demo. This is a mag switch, pneumatically operated on-off magnet. So we can show how we can pick up things that are metal. And we just have a simple on-off manual valve that we can turn that on and off with. So we will continue to step around this way. This here is our encoder cylinder, which you'll notice here there's a cable coming off here. We'll show you where that goes here in a second. Note that both pneumatic ports for the encoder cylinder just have a silencer, so you do not add compressed air into them. On the back side here, what we have here is, this is our proportional valve that piggybacks with also the 2-2 stop valve for safety shutoff and closure. So this line here is air pressure coming in from the air preparation. This connection here is the electrical cable coming from the encoder cylinder. This connection here, this purple cable, that's the CAN connection, or the CAN open communication that is being reported back to the controller cabinet. I'll show you here in a second. And then the stop valve has dual 24-volt coils for control here. Then on this side, this thing here, this output is to the working cylinder. This is the pressurized, proportional pressurized air for balancing. And then this 6mm line is actually the input tube coming from the handle, the operator handle. So as the operator pushes or pulls on the single acting cylinder or the handle, the differentiation in pressure reports back to the proportional valve and then gives a signal to the controller about what to do. Then next we have our controller cabinet here, and our controller cabinet has an e-stop on the top, but inside our cabinet here we have some breakers, a power supply. This is our controller here. You can see we've got a couple random cables here that I've wired in. We'll show how the free inputs work a little bit later. But I just wired up a single switch here, and we can play around with these 3 inputs that I made. And then we have just a terminal block for wiring all of our I/O. This is an Ethernet connection. There's actually a port on the bottom of this cabinet. We can connect our RJ45 cable. Lastly, we have our air prep, just an on-off valve with the filter regulator and a separate filter. So I'm going to close this cabinet, and then what I'm going to do is show you a quick startup. So we're going to turn the air on. So we roughly have around 6 bar air. And then I'm going to reset the e-stop, because what you're going to notice here when I reset the e-stop, so this would be a system that has already been parameterized or commissioned, but this would be what happens during a normal startup procedure. So when you reset the controller, you will immediately get an error. So you have to reset the air and then turn on the enable, and you'll notice some sounds coming from the back of this. That's actually the proportional valve doing like a self-check, a self-test. And then if it passes the self-test, which obviously it did, we have a system enable. And we're in load guided mode, but just to show you here, we can go back to hold mode or back to load guided mode. So the system is not referenced yet. So the first thing you have to do is actually move the handle until you get the sensor switch to see the piston magnet. So the system's in the up position. So I'm going to drive this handle down, but I'm also going to zoom in here until you can see there, you just barely saw it. So all it has to do is see a pass of the piston magnet from the sensor, and now the system is ready to go. So here again we have our Yhbp demo. We are connected up with an Ethernet cable to the controller, and I pulled up our web visualization through web server. Within the Yhbp manual, you will have a set IP address from the factory, and you will have this information where you can type this into any browser and get connected to the controller, which I've done already. So we're logged in. You should see my camera here. This is the actual demo that we're working with today. And you're getting some real-time feedback here. This is actual pressure that it's using right now to balance this load. You got some position here, some actual mass that it's saying through the closed loop calculation. And then these are just modes of operation that we'll be referring to here in a little bit. And then an error signal down here. So this gives you, this is your main page right here. You're also going to have these 4 tabs here that we'll refer to. This system has already been commissioned, so it's ready to go. We're not going to walk through every single commissioning step, but we will kind of hit on some of the things that are important. So for number 1, we're going to just look at the hold mode. So currently the system's in hold mode. We have a switch right here that declares hold or load guided mode. But for hold mode, it's basically doing what you think it should do. It's going to hold the position. So if I don't press on the handle, if I simply just push on the tool itself and try to make it move up or down, what you're going to notice is if you look at the position in this screen here, you got actual position. So it's trying to hold 219 millimeter position. So as I push down, you can see it's probably going to move a little bit. And as I let it go, it's going to try to get back to 219. And also if I pull up on it, it's going to try to resist and hold that position. So hold mode obviously is going to secure and hold the load at the position that it was left at. The handle still works with hold mode. So as you push on the handle or pull on the handle, obviously that's 0 gravity. You can move the tool all you want. But if someone puts a lot of force on the tool or tries to add weight to the tool, it's going to hold position, obviously. So as we take weight off, so you'll notice here that we have an actual mass of 92.3 kilograms. As we take weight off, that's why we have these plates here, you should see a drop in the mass. So the actual mass has started to drop, and the position basically has stayed roughly where it needs to be. There is a little bit of float sometimes, depending on how much weight you're actually taking off. But the other thing to notice is that we're not using a lot of air pressure right now. So that's another topic concerning sizing. You can oversize the system. In other words, if you had a weight that was too small, weighed very little, and you had too large of a cylinder, um, the proportional pressure regulator likes to operate in pressure ranges of 1.5 to 2 bars is what's cataloged at. It's probably better to keep it somewhere around 2 bar. Anything less, sometimes the feedback isn't as responsive. So this demo actually could have been built with a 63 millimeter bore cylinder instead of an 80. That's why we have so much weight on it. But it does basically what you need it to do. As we add weight back on, you'll see the weight return, and the position will be held roughly in the same position. So hold mode works with the handle. Without the handle, obviously, it's going to resist and return back to the last position that it was left in. You can turn off the handle mode. The handle is obviously an air cylinder, so there's nothing really, you're not turning off the air to it. You're basically turning off the bit that's in the controller that uses that differential air pressure in the up down. So you can turn off the handle and the system won't work with hold mode. In other words, it'll still resist what you're trying to do, but it'll return it back to where it's supposed to go. So handle mode on. So if you're trying to change a weight, picking up something heavier, picking up something lighter, dropping off a tool, picking up a tool, etc., hold mode is designed to be used for that motion. So, for example, I've got a mag switch magnetic gripper mounted to the bottom of this tool, and it's controlled pneumatically. So if I come down here and I turn this on, so hold mode is designed to do exactly that. It's designed to pick up and drop off weight safely. It will recognize the new weight that it picked up and dropped off, but that's kind of the way it's designed to do. Turn the magnet off, and you've dropped off the weight. So that's hold mode. Within hold mode, you can put a limit to what the system can see weight-wise. So for example, let's say for safety reasons, you didn't want an operator to try to pick up something they shouldn't be picking up. Whatever that could be. Maybe that was an extremely large part, a toolbox, a person. Maybe you don't want someone hanging on it. So for example, I'm going to set my microphone down, but what I'm going to do is I've set a mass limit on this system, and the mass limit is designed to be used to protect this demo here from seeing too much weight. So I'm going to set my microphone down, and I'm going to show you what happens when you put too much weight on the system. So my weight plus the weight that was on there, obviously we have a fault now. You can see we physically have a fault on the air LED. And then if you look at our software here, we have an error down here. So what's happened here is we've exceeded the mass limit. And the way you can see that is if you go to the diagnostic screen and you go to the error log, what you'll see is you have a maximum mass exceeded. Now there's some other things that it also saw because I stepped on it with quite a bit of speed, and so it saw pressure deviation in the cylinder. It saw an increase in velocity in how fast I moved it when I stepped on it. It also had obviously um, the mass that exceeded when I stepped on it. So all these things you can change. You can change the threshold value. You can also ignore it. You can turn it off so you don't even see it. So maybe you don't care if you want to see the velocity change, or you don't want to monitor velocity, but these are all things that we'll show here as we use this tool. Um, but you get the idea. So to reset this, all you have to do is hit the ear reset, and it's ready to go. So that's hold mode. The next video we'll show here is load guided mode, and we'll show some more things about the software. Now we're going to show load guided mode. So we've switched over from position hold mode to load guided mode via toggle switch. And so one of the things we're going to talk about with load guided mode is why it's so different than hold mode. So load guided mode allows the operator to still use the handle mode. So you still have, the full control over up down with the zero gravity effect here. Um, you still have, you're getting the pressure that we saw earlier, the position feedback, and the actual mass. But load guided mode is designed to take the weight that it sees when you have picked something off, or picked something up, or dropped something off from the hold mode, and then switched over from hold mode to load guided mode. So for example, we have 92.1 kilograms when we had dropped off a plate or picked up a plate from hold mode in the previous video. Now we're in load guided mode. It's only supporting the closed loop for that exact weight, at 92.1 kilograms. So if we take weight off of the system, if we remove plates, the tool is actually going to rise, because it's only designed to see or support the 92.1 kilograms. So load guided mode allows you to also manipulate the system. So let's say I want to make some slight adjustments to the tool. You could drive it with the handle still and get it close to where you want. Let's say you're assembling something and you need to put some bolts in the part to attach to a mating part. You can drive it with the system with using the handle, get it close, and then let's say you needed to move it a little bit, up or down just to align some holes. Load guided mode allows you to put force on the system and move it by hand. So that's the biggest difference in load guided mode versus hold mode. So let's say we had driven it to this position here, and I take off a plate, and I take off another plate. So watch this position here as I take weight off. So we're at 114.1 millimeters. Now it's starting to move. So that's normal. So customers need to understand that as they're picking up parts and dropping off parts, they need to use hold mode. And then as soon as they get the part that they need and they need to further move that part around, they need to switch it over to load guided mode. Otherwise, in hold mode, you wouldn't be able to move the system manually without the handle, because it'll fight back. Where load guided mode, it doesn't do that. It doesn't want to fight back. It wants to see the weight that you've got. Okay, so that's the biggest difference. You still have the same fault thresholds, so you can still create limits for velocity. You can still create, obviously, a mass limiter, but obviously if you put more mass on this, it's going to drop, like we talked about, very similar to taking weight off. If you add mass, it's just going to push to the ground. And potentially you can set software limits. We haven't talked about that yet. We'll talk about that here in the next video. But you can create software limits so you physically cannot drive the tool to a certain position. So let's say you wanted to say, 10 millimeters from the floor and 10 millimeters from the above, mounting ceiling or whatever it is. You can create a software limit that you can't physically drive the tool to. So if you wanted to turn the handle off in load guided mode, obviously you're not really using the handle right now. It's just using the force of what I'm doing. I'm manipulating the load guided mode, obviously. So it doesn't really make sense to have handle on or off. That's up to you. But to me, it makes sense just to use either if you prefer. Now we're going to show some special features of the software. So from before, we showed how we can use the tool to pick up some kind of part using the hold mode. We have allowed full stroke limit of this actuator. So right now, if we go all the way up to the top, and we notice the position that we have, it's 376. This is a 400 millimeter stroke cylinder. We are limiting the fully retracted position. Nothing to do with the cylinder itself, just mechanical stop from the tool. And then all the way down, you can see the pickup position is somewhere around 12 millimeters, 11.9 is what we show right here. So let's say for some reason you wanted to limit the operator to be able to limit the operator to see that tool. So if you wanted to create a software limit, what you have to do is you have to come in here to program mode, and within the velocity configurator, you'll notice here that we have software and positions. We have the upper limit and we have the lower limit. So right now, just seeing what it has, it can't even get to the upper limit. So 376 is the limit on that. And then the bottom limit, we can't even get to 5 millimeters because the pickup position for the plate is at 12. So what I'm going to do is I'm going to show you two ways in which you can set a software limit. The first way is to physically just go to that position, kind of like an auto teach. So you physically drive it to a position, let's say wherever that is right now. We're at 90.5 millimeters. And if you just want to set that as the lower limit, all you do is just click set. So now that lower limit is set at 90 millimeters. And how you know that is just to show you, I can't go down, but if I go back up, I can still go to the top, which is 376 millimeters. As I drive down, it's just going to stop. I'm trying to push the handle down to make the system go down, but it's physically not allowed to go. The valve is shutting down and not allowing the system to go any further. So that's one way to do a kind of like a software limit on the fly. The other way you can do that is you can just simply type the value in here. So I'm just going to type 5 millimeters and hit enter. And then now what you'll notice is we can go down and pick up the tool again if we want to. So that's just a quick and easy way to change software limits. The next thing I want to show you has to do with this output configuration here. So we do have 5 freely available inputs that you can use on the controller. And so you'll notice here this X1 through X5, and in parentheses the 3.1 through the 3.5. These are the physical wiring locations on the controller. So here's a little snippet here of what the controller looks like. And what you'll notice is this X3 here, dot 1 through 5. These are your freely available inputs that you can do. And so what I've done is I've set up a few examples to kind of show how you can use these free inputs. So for input 3.1 or input 1, I have set a position to go to of 150 millimeters, and I've also set a velocity of 150 millimeters per second. So when you are in position hold mode, you can use these free available inputs to do certain things. Some of them are not available to be used in load guided mode just because of safety reasons. So for example, I'm going to open up this cabinet here, and I've just wired some, um, you know, flying lead wires into the inputs. So I'm gonna toggle 3.1, and you'll notice this bit will turn blue, and you'll watch the system and see what it does. So as it's showing this example here, just kind of keep an eye on this actual position here, and then keep an eye on this 3.1 bit. Okay, so I'm going to turn it on now. So I just made a way to move this using a digital input. Kind of a nice thing. The next one I want to show you is this move down feature. And so when this input is high, I just put a distance of 20 millimeters. So right now we're sitting at 159.3. So when that input 2 is triggered, it's going to move down 20 millimeters. So hopefully we see this somewhere in the 180 um, position wise. So I'm going to change wires here and put my switch on the second wire, and then watch X3.2. So I moved another 20 millimeters. Actually, I went the wrong direction. I told you the wrong direction. It should have gone to, I told you it should have gone to 180, and I should have subtracted. My fault. I was going the wrong way. But it did move down roughly, 20 millimeters. One thing to remember is this is servo pneumatics. This is not servo electrics, especially in a vertical orientation. You're going to get a little bit of a float. You're going to get a little bit of an overshoot or an undershoot. So just kind of be aware of that. These are not made to be, extreme, repeatable, accurate positions. That's a perfect example just to show. And then lastly, the third input would be the move up by 20 millimeters. So I'll change over my wires here, and I'll toggle X 3.3, and that moves up by 20, moves up by 20. I'm just toggling this bit. So there's a variety of ways which you could use that. Just kind of a nice way. But within the software, you're going to have a drop down here. And within the drop down, these are all the available things that you can do. So I'm not going to go over every single one of those, but you get the idea. You set what you want to do, move to position, move up, move down, change the mass, etc. A lot of nice things you can do there. Then on the output side, similar with the drop downs, you do have 3 configurable outputs. I don't have these set for anything right now, but if you wanted to wire to X4.1 here, X4.1, X4.2, or I'm sorry, X4.5, they skipped on me, and then 4.6, these 3 outputs, you can have, a signal to higher level PLC or to a light or whatever you feel like you might need. So, the next thing I want to show you is operation. Let's say you, just for setup purposes or troubleshooting, we have a trace screen here. So for example, right now I've selected the pressure value. So going in the vertical, we obviously have 0 through 8 bar. and then this is a sampling time in seconds. And so, if you wanted to drive the tool up and down and see what kind of response you're getting pressure-wise, that's one thing you can do. If you want to, change that to position and see what it looks like. Now instead of pressure on the vertical, now you've got position of the encoder, so you can watch and see how that responds to over time, and then velocity and mass. Um, so last but not least, we're just going to quickly go through the commissioning steps. Like I said, I'm not going to show you everything, but in general, this is very similar to any kind of servo system that you would have to load parameters for the closed loop calculation. Um, you have to um, show functionality through some kind of um, parameters that the system has in it physically. So, for example, you have to tell it what size cylinder you have. You have to tell it how long the stroke is. You have to tell it the orientation. So in other words, not so much the orientation at which it physically is connected, such as vertical or horizontal, but you have to tell it which side of the piston that the air connection is on. So for example, this one here is vertical rod down, and then the air connection is on the rod side. So I would select this here. And then obviously you're going to have to tell it the size of the rod, because it's going to do a calculation based on how much pressure and force it has. You've got limits on how you set up everything here. This is a really important one here, the mechanics. So you got two choices here. You have lifting column or you have parallel kinematics. We talked about that in one of the earlier videos. If you do select parallel kinematics, you obviously have to give it some kind of ratio, some kind of mechanical advantage. Supply pressure, self-explanatory. Handle direction up and down. You can have it up or down depending on, the design of your tool. You do have some gains here. The gains are how fast or slow your handle responds to the operator. So if you have an operator that's not as strong and you want a little bit of additional support from their handle movement, you could actually change the handle gain to make it more responsive. Or if you've got an operator that's a lot larger of a person, a lot stronger, and you want to restrict the up and down pushing motion of what that operator can do, you actually can change the handle gain to make it less responsive. So yeah, just some things you can do there. But you're basically going to walk through each one of these, and you're going to do some tests, that walk you through how to configure it. It's going to do some tests for pressure and setup of limits and things like that. All these steps are available when you look at the user manual and the commissioning steps for commissioning the system. You do have, other limits you can set that we talked about earlier, very similar. And then, of course, you get to the end and you want to finish the commissioning, and then you're pretty much done. So for that, that's pretty much it for this demo today. Appreciate your time, and hope you're successful in commissioning your Yhbp. If you do get stuck or need additional support, you can go to Festo.com and just type in Yhbp into the search box. Go to the software tab, and there's technical data and all the user manuals for all the startup and commissioning for your system. Thank you very much.